Hello, AP Stats nerds. We're back to make another graphical display of data. And notice here we have Miss Carrie Bates' statistics class, and here's the scores. And we've been asked to create a Stemplot of the data. And I don't think we've done a Stemplot yet, so we need to talk about what that is, what that looks like, and what advantage it may have over some other kinds of graphs that we can do. So when you do a Stemplot, what you're going to do is you're going to draw a vertical line, and on one side of the line, in this case this is all tens and ones places, right? You're going to put, let's see, I got 50s. Are these in numerical order? Oh, bless her. Okay, so we actually have these in the proper order. If they're not in the right order, it's really hard. So we go from 56 to 100. So I'm going to go put the tens digit down. So 5, 6, 7, 8, 9, 10. And that's the stem part of it. The leaf part, a lot of times it's called a stem and leaf plot, and in this case it's called a stem plot, but it's normally called a stem and leaf, and the leaves are the ones digits that go with it. So notice that we have a 56 and a 58, so if I write a 6 here and an 8 there, that indicates 56 and 58. So that's the tens digit and these are the ones digits. So because we need to communicate that, we have to make a key for this. So we might write over here 5/6 is equal to 56. And we're letting the reader understand how we're writing down the information. So notice I don't have any 60s in here, so I'm just not going to write anything down. And then I have 3, 5, 8, 8. So if there's twice, you write it twice. And that's it. And then I have 0, so there's 0, 3, 4, 4, 6, 6. 0, 3, 4, 4, 6, 6. 7, 8, 9, 9, 9. 7, 8, 9, 9, 9. And then for the 90s, I have 0, 1, 5, 7, 9. 0, 1, 5, 7, 9. Now notice I'm trying to line these up underneath the other ones, and the reason I'm trying to kind of do this, and I just looked up and this is so crooked, so I'm going to try to straighten this up a little bit. Sorry about that. But the reason you try to do that is you're trying to look at the shape of the data, so you don't want to, you want to kind of, to do that, you want to keep everything kind of lined up if they do line up. So let's see, it was 0, 1, 5, 7, 9. So you can see how many data points there are compared to the one above it. So you try to kind of line them up a little bit. And then I have 1, 100. Okay, so this is called a stem plot or a stem and leaf plot. Notice that all the tens digits have to be here even if there is no leaves, or ones digits to go with that 60. What that means is there are no 60s is kind of how you read that data. But it also lets you know that there's a little gap here in the data, right? So it lets you see a small gap, not a big one, but a small one. And it lets you analyze the data a little better. So don't just leave out your tens digit just because you don't have anyone in that class, okay? All right, so what is so cool about this? Watch this. This is the reason I did this on the document camera. Look what happens if I turn it around. Now it looks just like a histogram. Why? Because isn't this from 50 to 59? Yep. And these are all the 60s to 69, like this whole, well, there's nothing there. And that's 70 to 79, like that's kind of like a bin, if you will. And this is 80 to 89, that's where all those go. And this is 90 to 99, and then that's 100, right? So it's kind of like you have a histogram, but it can be written like, well, it can be written vertically or horizontally. You normally see it like that, but you can really see the data. Okay, so we're going to look at that again. What is different between this and a histogram? Well, the histogram, you don't know what the particular data points are. You just know that there are some in there. I actually can see the data points as they're here. So that is a very big benefit to a stem plot, is that you can actually see the data points where you can't in a histogram. Because if I had, let's say all these were 80s, every single one of these. There's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 data points. Let's say they were all 80s. In a histogram, there would be 11 scores in that bin. And it would be the same if these were all 80s, or look at all these great 89s, which I really like. I want them to be higher. So that's the downfall of the histogram, is that you can't see the data. You know which bin it falls in, but you don't know exactly what it is. In a stem plot, you do know what the data is. So that's a good thing. We like that. So let's talk about the shape of this distribution. So in the last video, we talked about, are you symmetric, are you skewed right or skewed left? Notice that most of the data is over in here. So I'm going to put my hand where there's not a lot of data, and that's right there. There's not a lot of data in the range right there. There's not a lot at all. So this is my, I'm going to show you this. This is my left hand. So I'm skewed left slightly. I wouldn't say I'm way skewed left. I would say I'm slightly skewed left. I know those words, it's crazy. So I would say this is slightly skewed left because the majority of the data is on the right, and there's not very much data on the left. See how your hand makes an L? There's not much data on the left side, so it's skewed left slightly. All right, so there's a stem and leaf. At this point, I'd also like to show you what this data would look like in a stem plot, in a dot plot, that is a stem plot, and also what the histogram looks like. So I've made those. This did not ask you to do that. I'm just being a little crazy. So here is a dot plot of that same information. So I'll tell you what I'm going to do. Sorry, be patient with me. There's the values, and then there's a dot plot. In a dot plot, you plot your values along your continuum, and every dot means there's one of those values there. And so like this is 52, 4, 6, 8, 60, right? So this point right here is 2, 4, 6. This is 56. And if there were another 56, I'd put it above it. So I can come over here and talk to you about these scores. I can actually figure out what they are. So that's 90. So that's 89. Nope. That's 90. So sorry. That point right above 90. There are 3 89s. And that's in the middle of the even slashes. So that's 80, 82. That's 83 because that's in the middle. 84. So all of these little squares represent 2s. So if you need an odd number, you just put it in the middle. So I can tell you very quickly, if that's 90, there are 3 89s. So you just stack your plots on, you stack your dots on top of each other. And that's called a dot plot. And we do that a lot in AP Statistics. It's just a quick graph, but it shows the shape. Now you can really see, now look at this range. See the range? There's not a lot, look at that, there's not a lot on the left, so that's skewed left. Most of the data is on the right hand side. Okay, you can really see the skewness there. And then also I wanted you to see the histogram that goes with that. And you can see there's not a lot of data on the left, so I'm skewed left. So there are 3 different ways that we can represent this data so far. We've got our original stem plot, this is right there. So there's your stem plot where you can see all of your data. There's your dot plot where you can figure out your data and see your distribution. And there's your histogram, which gives you a shape, but you really don't know what the data is inside of it. But your calculator can do this graph, and so we'll use that capability to let the graph kind of help us out some on that. All right, so that is quantitative data plotted 3 different ways, and the next one we'll talk about a back-to-back stem plot.